Welcome to this Mobile World Live webinar, Seizing the Connected Vehicle Services Opportunity, presented by the Automotive Edge Computing Consortium. I'm Martha DeGrasse, U.S. Contributing Editor for Mobile World Live, and I'm joined today by four distinguished panelists. Before we begin, I would like to share a brief overview of the Automotive Edge Computing Consortium. The Aecc is an association of cross-industry global leaders working to explore the rapidly evolving and significant data and communications needs evolving and instrumenting billions of connected vehicles worldwide. The Aecc's goal is to find more efficient ways to support distributed computing and infrastructure network architectures to support the high-volume data needed for intelligent vehicle services. Members are key players in the automotive, mobile network, edge computing, wireless technology, distributed computing, and AI markets. For more information, you can visit aecc.org. And with that, I'd like to introduce you to our panelists for today. First up, we have Roger Berg, Aecc Communications Vice Chair and Vice President of DENSO's North American Research and Development Group. Roger, thank you so much for being here today.
Good morning, Martha, and good morning, everyone. It's morning where I am, maybe not where you are, but it's morning here. I'm excited to be part of this webinar today. There's a lot of neat things going on in our industry, and I'm happy to talk about them with all of you.
Yeah, we're excited to have you here. It's going to be a really good webinar. We also have Krister Boberg. He is Aecc Secretary and Director of Group Strategy at Ericsson. Krister, welcome to the webinar.
Thank you, Martha. And I would say then good afternoon, as I'm in Sweden and it's afternoon here. So I'm, as Roger said, very excited of being here and having the opportunity to present. I think the work we have been doing the last years in Aecc will have a big impact on the automotive industry going forward, and we see that there are many interesting topics to discuss today. Thank you.
Definitely. We also have Bruno Fernandez-Ruiz. He is an Aecc member and co-founder and CEO of Nexar. Bruno, it's great to have you here.
Thank you, Martha. Glad to be here too. I'm really excited to have an opportunity to chat today and talk about what we've been doing within Aecc around situational awareness and making sure that we move forward, understanding how transient changes happen in the physical world, and the automotive industry can benefit from knowing when they're happening as close to real time as possible.
Great. Okay, and last but certainly not least, we have Tim Hatt. He is Head of Research at GSMA Intelligence, and he is going to begin our webinar with some opening remarks.
Thank you very much, Martha, and great to be here with everybody today. So as we were saying, we're going to be talking about the move to the connected vehicle and what that means and how we get to that point. And I wanted to set the context leading into that discussion because this is quite a fast-moving area. I am an analyst in the telecom sector, and we have a team of people that are looking, continuously at how the automotive market is changing and how advanced communication is supporting that. And I think this next, 5 to 10 years will be another moment of significant development. So hopefully we can lay some of the key influencing factors to that out before we get into some of the other topics. So I think the first point to note is when we look at a kind of market size for what connected cars or connected vehicles could become, it's important to sort of put that in perspective. We have a range of IoT forecasts at an industry level. And for the connected vehicle segment of that, we think this will get to around 900 million assets by 2030, so over the next sort of 8 years. Now, that's not necessarily cars, but that's the connected systems within vehicles, infotainment, mapping, other telemetry applications. And whilst this is, starting historically from a low share of the vehicle market, that's really changing quite quickly as you get new car sales filtering in. and as the EV market, the electric vehicle market, begins to take hold in the coming years. So you can look at the geographic distribution there, and the majority, largest share will come in Asia, but actually that's the leading effect is still in Europe, the United States, and some of the higher income markets in East Asia as we go forward. But the really key number, and why this, I've called this context the monetizing the connected vehicle, is that this translates into an incremental revenue opportunity. You'll get different estimates depending on the modeling used, but we think it's in the sort of $4 billion range alone, and there are adjacent connections to that which could make it higher. And I've talked about some of that upside there. So this is a really significant sort of opportunity for the mobile operators, for others in the automotive ecosystem to increase the value of automotive vehicles through connectivity. Let's talk about some of the enablers that are being put in place and still need to be put in place to make this happen. We've talked about 5G networks for some years now. I think what's changed is we've seen an acceleration in network rollouts through the pandemic, despite the obvious financial implications that COVID presented. And as of now, we've got over 200 mobile operating companies with live 5G networks in the commercial marketplace, and that's just under a third of operators worldwide. You do have that vanguard of countries in China, Japan, Korea, Europe, and the United States leading it, but it is starting to spread. Now, automotive comes into this for a whole range of applications, which we'll talk about, but that 5G infrastructure is crucial for low latency connectivity, which is really important in a mission critical setting when you're talking about safety applications, mapping, and others that the vehicle market is seeking to leverage. I think it's also important to present that it's not just 5G expansions that matters, but the type of 5G networks that are being expanded. So most of the 5G networks have historically been on a non-standalone configuration. That's essentially where they're paired with existing LTE networks and building on that. But what's changing is that a lot of operators are starting to move to standalone, or SA, and that is essentially a dedicated 5G core and greenfield build-out. Now, why does that matter? Well, it matters because that is the underpinning for the low latency connectivity and a lot of the mobile edge computing applications that can facilitate the monetization opportunities in the connected vehicle space. So this was really a China story in the early years of 5G 2 or 3 years ago, but that's starting to spread out. And that will continue to spread in the coming months. Now, one of the other drivers for connected vehicles is the return of roaming. This is slowly coming back. It's not yet back to what it was pre-pandemic. But if you think in the context that roaming revenues were hit to the tune of 20 to 30% in 2020, when lockdown restrictions and international travel ground to a halt, we're starting to see a rebound in volumes, but perhaps more importantly, in terms of how you look at the roaming business model. I'm showing some data here on the right from a survey we ran of the operators last September, looking at whether they thought different vertical segments would be bigger or smaller than before the pandemic in a roaming context. And you can see that automotive is one of the only sectors that people think will be a net bigger opportunity. And I think that speaks to some of the applications we've talked about, as well as the need for trusted connectivity in cross-border logistics and as global trade starts to recover. So this is really, I think, a series of sort of forces that will be aligning together to help drive this forward. And then finally, we can't talk about the future of automotive without talking about the softwareization of the connectivity and the provisioning of that connectivity. And this is where eSIM comes into play. eSIM has for several years been an enterprise, an M2M sort of first story before starting to move out to smartphones. But this continues to gain traction within the operator community. And this is really more of a when, not an if story. We know over 230 operators and MVNOs have already launched eSIM in their networks, split between consumer and enterprise. And as I say, by 2025, that will essentially be the entire industry. Now, from an automotive perspective, the implication here is that it really reduces the cost structure of how you provision vehicles with connectivity and makes it much easier for owners to move to flexible plans, data plans, and other connectivity options as they move through different nationalities. So I think when you combine the 5G networks and the standalone, plus the move to eSIM and the demand starting to return, we're seeing a lot of forces moving in the right direction for automotive. Of course, there are barriers and challenges, which we'll get to, but I think proof points are to the next portion of the discussion. Thank you. Roger, are you there?
Tim, thank you very much. Up next, we have Roger Berg of DENSO. Roger, are you here?
I'm here. I didn't think I was next, but okay. I thought Krister was next. Sorry.
Krister,
Yes,
are you here?
I think it's me here. Sorry for that.
No problem.
So I think let's move to the next slide here. So thank you, Tim. To start off, we would like to talk a little bit more about the opportunity here, outlining why we are even looking into the topics we do at the Aecc. And as we see here, it's a huge value and it's a huge opportunity here. If you look at what GSMA predict, it's a $198 billion market by 2025, which is obviously huge. And by then we will see, according to SPD and other sources, that there will be among 400 million or even more connected vehicles which have what we call embedded connectivity, where the connectivity is either 4G or 5G type of connectivity included in the car as such. And also very interesting is that what consumers or users of the car are willing to pay a lot of money, up to $180 or maybe more per year to have what we call a full set of connected services, according to PwC's report that came last year. So this opportunity is apparently very high, but given that it's not only an opportunity, this also of course poses a lot of challenges, because when we now go forward and we will see plus 400 million vehicles connected globally, and we see 100 million new cars with embedded connectivity coming each year. This will pose, of course, not only new connected vehicles to the network, but the amount of data being basically sent, but also retrieved or transferred between the vehicle cloud will increase heavily. And we claim then from Aecc that this will be up to 1,000 times more data being sent in 2025 than we see today. And this, as I said, is a heavy uplink division here compared to how you see the networks being deployed today, which is focusing on what to say, consuming data from the cloud. You will see a tremendous move from that, and automotive is one of the big verticals that will bring this. There are others as well that you can think of, and by that we see that you have 1 to 10 exabyte data per month being transferred to the cloud. And why we say 1 to 10 is dependent, of course, how the networks and how the clouds, etc., will support this. Because in the current model, we see that the solutions and the networks are not really deployed to handle this. When you look at what the automotive industry really needs, and that was a little bit what Tim touched upon before as well, is that you need a consistent behavior on a global scale. And that requires that for an automotive player, an automotive maker, and a tier one, an application provider, it has to work in a similar way, which means that what we are trying to do now in Aecc is to say that this is the way that a network shall be configured, and this is what a vehicle and an OEM shall use. So we are, what we say, creating blueprint configurations for how this should do. And this is what our working groups are doing, and this is what our technical reports include. Little bit more on the details then, because when we talk about 1 to 10 exabyte, it's obviously so that we need to tell a little bit more about what it is. First of all, this is general data. I mean, it's data coming from the sensors, ECUs. That could be video streams, that could be images, that could be telematics data. It could be different kind of analytics data coming to and from the cloud. As I said, heavily uplink focus on that. And the main use cases that we have been looking into them from Aecc is what we call a number of model use cases. If we take the intelligent driving use case, you could say that this is an ADAS type of use case, and today it's very much related to the safety type of discussions. Over time, that will also encompass autonomous drive, but you can see it as a way of improving the driver's behavior, the car's behavior, etc. And one example that we describe also in our white paper is where you monitor the driver's conditions, so to say, biometric data, evaluation of how the car behaves when the driver drives, and then you analyze that and you send data back to the driver and to the car to adapt to the behavior, both maybe informing the driver of what kind of measures that we take, but also the car. And that is something which will be very, very different in the future, and we will see a lot more what we call analytics at the edge for that. The second one is high definition mapping, and there are different kinds of high HD maps discussed. In the Aecc, we are talking typically about the what we call the efficiency and the support type of HD map, not the sub-millisecond type of update that we could see in very, very specific environments where you typically steer the vehicle from the map. That is not what we talk about here. These are the different kind of layers from static to dynamic to subdynamic to dynamic. The last one, which I think is very important, is what we call the V2Cloud Cruise Assist. That is a model where you basically use the 5G, well, you could use the 4G as well, but the 5G network to do what we call V2Cloud to vehicle, or vehicle to cloud to vehicle. You send data from different vehicles via the cloud, and that is extension, it could be, or a complement or a replacement of short-range technologies such as PC5 or DSRC. And that is typically used in the cases where you don't have a short-range possibility, or where the environment doesn't support it, or where you have a line out of sight type of use cases. And it's a very flexible way of sending data between different vehicles and environments and managing that data on the edge. Then we also have what we call mobility services, which of course will use the same kind of mechanism. And then we have also looked into more specifically how can we use that data that vehicles generate for other type of business, such as finance and insurance. So that is main topics that we are discussing in Aecc and that we want to share from a general perspective. And having said that, we should remember that all of this data will have to be transferred and also manipulated and analyzed, sometimes at a very specific and early stage, which means that there are different ways of managing data and different levels of what we call edge compute. Some data is managed in the car, some data is managed in the close adjacency to the access point, what we call sometimes far edge, and some data is not necessarily so that it has to be computed on local geographical statement. You would have handled that in the standard cloud today. But we should remember then that all these vehicles are moving around as well. So there's a big work on how do you manage what we call edge instances of edge data offloading in a very mobile environment where you also have different players and you have a consistent need, so to say, over multiple operators as well. So with that, I think I hand over. I think it's Roger.
Thank you, Christer. Let me. So here we have an illustration of really the process we use within Aecc about going from use case that Christer so well described through understanding the needs of those use cases, creating a technical solution or an architecture or a feature implementation. And when I say implementation, I think that's one of the important things that Aecc does. And today we want to introduce and promote our proof of concept program. One of the things that Aecc does that I think is quite valuable, and one of the reasons that DENSO and I think a lot of other companies who are in this organization think it's valuable, is that in a consortium like Aecc, we can take this use case development that an auto manufacturer or some transportation manufacturer or a fleet owner can look at commercializing and making as part of their product portfolio. But really, in order to have that use case, as Christer described, implementable, you need to work in concert with your mobile network operator, your data warehousing, your compute, your off-board compute partners. And so in this consortium at Aecc, we all kind of work together in concert. It's not just a car manufacturer going to a single mobile operator, or it's just not a single mobile operator going to a single car manufacturer. It's a consortia-like work, and I like to say work in concert. So what we do in Aecc is take those use cases, provide the technical solutions that adapt or comply with the requirements that the use case defines, And then, all importantly, we move that technical solution to a proof of concept, an actual demonstration of the feature or demonstration of the architecture that really shows how the work that AECC does, both in the use case and the technical solution, and its implementation can be commercialized. And we introduce that to the mobile edge computing community in a promotion like this. So I'd like to describe this a little more eloquently with a short film clip. So please indulge with me for the next couple of minutes and get a better description than I've given on our proof of concept effort.
Connected vehicles and their services are in everyone's near future. All of these services will require a much larger data transfer capacity from the vehicles to the cloud than what is available today. The AECC is dedicated to helping address the data transfer requirements of this growing ecosystem. Our Proof of Concept, or POC committee, is focused on developing technology demonstrations that bring these services to life. Let's take a closer look at some of our existing POC demos. Conducted by DENSO, KDDI, and Toyota, this AECC proof of concept demonstration simulated how to address network congestion for connected vehicles using an HD mapping application within an urban LTE environment. Global deployments of connected vehicles can climb to hundreds of millions and eventually billions of users, which makes the traditional mindset of throwing bandwidth at it to resolve network congestion simply too expensive and impractical to scale. Using existing network resources, AECC's low-cost distributed edge computing approach, known as Opportunistic Data Transfer, or ODT, enables network operators to reduce network congestion for a growing spectrum of mobile services. For connected vehicle services to work, mobile network operators need to solve the challenge of network congestion using network data optimization. This means that as vehicles and global fleets move through cities where there is a high demand for network support, they need to determine which data to prioritize. Vehicles will also travel through rural areas where there are vastly different connectivity situations and coverage on different corresponding networks. ODT helps prioritize data, moving low-priority data to off-peak hours, avoiding congestion that could disrupt critical connected services during peak hours. The results demonstrated that the AECC ODT framework is effective at optimizing the high volume of HD mapping data during peak and non-peak hours using existing network resources. To learn more and get involved, visit aecc.org/proof-of-concepts. This AECC proof of concept, conducted by Oracle Japan, sought to confirm the AECC's approach to enabling data integration of distributed edge computing for HD mapping and prove it as an affordable solution for HD map data. HD maps are a primary use case for connected vehicles. These maps consolidate static and dynamic information, such as the vehicle's position and its relationship to other vehicles, pedestrians, and obstacles, to help ensure the accurate, safe operation of connected vehicles. But creating and distributing an HD map in hundreds of millions of connected vehicles is a massive challenge. Multiple global and regional stakeholders require many data transactions with high capacity and efficient processing to keep HD maps up to date. Legacy systems are unable to perform these requirements on a global scale. This study simulated the AECC's concept of data offloading at distributed edge computing locations and tested the accessibility of this data. It also included the AECC's concept of edge server selection, which ensures that data is distributed and processing occurs at the server where the data resides. The results verified that AECC's approach to data integration enables interoperability with multiple clouds and up to a 10 times reduction in query latency using a subquery component. The study also determined the optimal driving route for each vehicle, considering factors such as road width and traffic congestion, with an average processing time of less than 200 milliseconds. To learn more and get involved, reach out today or visit aecc.org/proof-of-concepts.
So that was an illustration of a couple of proof of concepts that we've already done. I think now we switch to a description of additional POCs that are present today. I want to turn it back over to Christer.
Thank you, Roger. So to complement on what Roger presented and what we saw on the proof of concepts that has been created by the Aecc team, we just wanted to also measure or state what we also do. I mean, the technical reports that we are providing to the ecosystem is also available, of course, for anyone to use. And one example of such case is where Ericsson, together with Vodafone and Toyota, performed a proof of concept already back in 2020 based on a number of use cases and technical realizations that has been stated in our technical reports. I will not go through in detail exactly what has been done. That can be found on the internet. But in generally, this was about what we call make before break. How can we set up a connection? How can we make sure that the connection, when you change your gateway, what we call packet gateway or UPF, and you also change your edge instance, we call these things edge data offloading and MSP service selection. What happens when you move these, and how do you make sure that you don't lose the connection, and how do you make sure that you have as little interruption as possible? And then we compare that with the 4G network and evolved packet core, and we compare that with the 5G packet core gateway switching. And the summary conclusions was, of course, very, very interesting. But the interesting thing here is that Aecc is also inviting other parties to collaborate with the Aecc companies based on the technical reports and the white papers that we have done. And with that, I will want to hand over to Bruno for discussing further on the proof of concepts.
Thank you, Christer. So one of the additional POCs that we've been doing on the Aecc together with Oracle and KDDI, it's about understanding situational awareness, as I mentioned in the beginning, which really, if you think about it, is as we drive as humans through the streets and we realize there is a group of people about to cross the street, we think about a group of people crossing the street. We don't think about, there are 7 people and each of them is moving differently. So there is a concept as you drive of this notion of creating a situational awareness based on transient changes that are happening by aggregating all these individual events that our eyes are capturing. And the car is no different. We have sensors that are doing the same. But it would be great if all the cars could share that information. That's really the value added, that if I see that group of pedestrians crossing, people can get that sense of it. And it's a bit of a fast event. So that's what we've done for free street parking in Japan with our partners within the Aecc. And so I'll play a video now. It's just it's less than 2 minutes long, and then I'll explain a little bit about the challenges that we were trying to address there.
Proving scalable real-time detections in a dynamic edge environment. In April, Nexar launched a POC in Tokyo, Japan, with Oracle and KDDI's mobile edge infrastructure and the Automotive Edge Computing Consortium. The goal was to show how Nexar and the Aecc stack can shard down big geolocation challenges into scalable distributed edge computing. Vehicles with AI dashcams were used to detect open curb spots for other cars interested in parking. two types of network clients were used, dashcam and phone as a producer client, representing vehicles that detect free open curb parking spots. Web-based application as the consumer client, representing nearby vehicles consuming available parking spots in a given area. The street was divided into two different geolocation processing areas, each running in a different edge compute location. These edge locations were allocated as far as possible from each other, with no direct connection between the processes. When the producer vehicle is in motion, it detects open curbs on the side of the street. This detection produces a push notification that is consumed and visualized on the web app by the consumer vehicle. To illustrate the different geolocation channels, purple and orange represent two opposite sides of the road. By leveraging 5G and mobile edge computing, every vehicle can get a near real-time picture of transient conditions affecting its route. Being able to apply these dynamics in Auto Edge is critical in scaling cost effectively.
So I was mentioning, at the end of the day, what you have is it's a network of cars roaming around, and as Krista was basically referring to, the amount of data that they're gathering about these, 7 pedestrians crossing, about these 10 or 20 vehicles around them, around the traffic lights, the traffic signs, the situation of the road. That's a lot of data that has to be shared with each other. And if every car was sharing this data with each other, then really it's chaos. It's not just chaos, it's the car will be able to understand it, right? If I'm getting signals for every vulnerable road user, cyclist, or pedestrian around me as a car, I'm getting all these signals. The car is unable to make sense out of it. It's just too much noise. So the idea is to move into this situational awareness, but to move this data to somewhere where you can bring context into it, where you can aggregate all this data into one, you have to move a lot of data. And that's, if you look at a small city, even a small city with 7,000 concurrent drivers going around, collecting just a sensor video feed, not even LiDAR, that's like 100 gigabits second, something that cannot really reach the cloud, that you have to use at the edge. So the approach that we followed here to be able to do this aggregation and apply these functions, that logic that really interprets the situation, like free street parking, like a pothole, like a cone falls off the track, whatever it is in terms of the situation, is to shard the road into these geolocation divided edge processing locations or nodes. And each shard of these topologies is basically responsible for a little bit of the area that is consuming, and provides these situational awareness channels, like TV channels, that you subscribe to each of them. The shards then give you that ability to be dynamic. If they can become bigger or smaller, or they're elastic, because there could be more load in the evening, more load in the afternoon. There could be some games happening on a weekend. So all those things really is what this shard topology of the road gives you. The same elasticity and the same high utilization that we have come to expect out of cloud compute, really bring it to edge compute. But there are a number of problems when you do this. You have things like geoprivacy. How are you tracking the vehicles? You have issues like if I allocate too many resources in one cell, one shard, and the other shard, or I move between one provider, one telecom, to another telecom operator. A lot of problems that come with making sure that the dynamic allocation is happening and that a consistency of this allocation exists. You don't want stale data to be sent left and right, and to be subscribing to, oh, there's a group of pedestrians crossing, but actually that was earlier and it's on the wrong cell because I moved servers around elastically. And then finally, context switching, right? That as you start roaming and moving from operator to operator, are you actually preserving the context as a vehicle to have that high level mission critical service level that is required to be able to do this? These are all problems that we work within the forum of the Aecc, that this POC has demonstrated that the results that we achieve is really that we can use something like dash cams to steer the traffic of those dash cams to multiple edge locations. One was in Tokyo, the one was in Osaka, and that we can seamless allow that elasticity, that distribution, that ability to bring context and situational awareness with your privacy. If you want to learn more, about the POCs, about this POC, about any POC or the ACC, you can reach to the ACC, and I think Roger is going to explain a bit more about that now.
Roger, are you on mute perhaps?
I'm here.
Gotcha.
Thanks, Bruno. Yeah, I think the 4 examples of proof of concept that AECC has worked on show our results very well, and the idea that we can work in concert with each other, with people from different sectors like automotive, communications, cloud and data analytics, and applications and services like Bruno introduced, I think are quite compelling. I don't know if any of you have spent more than 2 or 3 minutes looking for a parking spot in these dense urban areas. I think that use case is quite compelling and provides a really good example for how members and in Krister's case, non-members can work with the community of AECC to really show some compelling use cases and some compelling results from working in concert with each other. So as Bruno mentioned, you can learn more about our proof of concept initiative, and if you like what you see, contact us to become involved. I think it's an outstanding opportunity for all of the mobile edge computing industry, whether you're a mobile network operator, a solutions provider, a technology provider, someone who works with automotive vehicle manufacturers or truck vehicle manufacturers. If you can see the benefits of how we can work together, I think it provides a very good, compelling story to come and join us and really invent for yourselves with others what the mobility future will look like on a global basis.
Thank you, Roger. And I think that members who get involved now will be highly involved in standards as they come around, and that will be important. And that leads to our first audience question. Since connected vehicles do require particular standards and specific provisions, can you say they are a different technology than IoT, or is connected vehicles a subset of IoT?
Krister, maybe I can start, and then please fill in the others. I think it depends how we look at it, because there are many. I mean, IoT is broad, of course, right? So I mean, it could go all the way from simple sensors, sending temperature data from a sensor every 250 bytes every 15 minutes, and it can be batched basically. So, and if you look at the car, it's obviously a very complex entity with many different kind of use cases as we have shown just. So in some sense, it is different than the general IoT, I would say, because it requires much more complexity from a network perspective. Now I'm speaking from a network and maybe a mobile network perspective. Then we also need to remember that we cannot build different networks for different appliances. So automotive, specifically the what we call the standard automotive with cars driving on general roads using the mobile broadband network, have to use the same network. So the networks need to cater for the differentiation of different use cases or different devices. And in this case, a device like a car will have many different use cases, and that could be, for instance, somewhere where you have different type of slicing setups perhaps not one slice for automotive, but different, because you have different type of traffics. So it's different from standard IoT, I would say, but from network perspective, it has to be handled as any other, or it cannot have specific network functions. It has to sort of work together with other type of device and applications. Maybe.
Excellent.
Yeah. I don't know, Roger, Bruno, if you have any other comments on that.
Yeah, I mean, I would make I think related to what you're saying is that IoT devices, actually radio frequencies and communication standards that happen with it are designed really for very low payloads and very low compute, which is the nature of IoT. So what they can really truly do is the many-to-many situation. I'm going to broadcast to everybody around me, or I'm going to broadcast to one person singly. But that it's okay for some certain use cases, which is, I want to move certain data from point to point, or I want everybody around to know that I'm here. But it's not that useful when you start looking at some of the use cases that we were talking about earlier, whether it was from the HD maps or the efficiency of the network, or the situational awareness, or the transient maps, which are a different species. So I think I would agree with you, and even the network standards and the wireless frequencies that are used are different on purpose to allow that differentiation and power profiles.
Okay, great. Thank you, Bruno. The next question is for you. Someone's asking about the proof of concept that you described with the dash cams in Japan, and whether that can be scaled in a bigger fleet with thousands of vehicles, and what that might look like.
Yeah, that's actually a great question. So what really needs to happen now is we've been running this kind of thing only Nexar, not with KDDI and Oracle. We've been running it in the United States, in New York, with a big ride-sharing mobility company. It really proves the value of doing this connectivity and solutions aftermarket and processing on the edge. But now I think what we have to do is to move to really test it on one of the larger fleets of the Aecc members, and there's several one of them that have really the ability to do it and to scale, and not just to scale in terms of the area, which is used a small area of Japan where we did it, not also to test the number of vehicles that are doing it, which I think is important, but also to test it in terms of the type of situational awareness that we're creating. And there are a number of things that we know are important to some of the other Aecc members, whether that's something on the road that just fell off a truck, or there's some debris, or there's something broken off a vehicle that's just blocking the road, and getting that alert. Maybe there's a vehicle stopped ahead, there's a vehicle on the shoulder. We come used to, maybe some people get that sort of alert sometimes with Waze nowadays, but Waze doesn't give you that real timeliness, nor it gives you really the context necessary for it. So at the end of the day, I think what we have to do is with the partnership with more Aecc members that have these larger fleets, is to really show value to the consumer, to those that are buying the car, to show the economic benefit and the safety benefit and just the comfort that this can bring to them, so that it becomes a mass market solution, which will then unlock a number of other situational awareness things during the driving. So I'm hoping that really would be the next piece of work that we take on.
Okay, great. The next question is probably for Roger or Christer, but anyone could answer it. What does the AECC currently see as the biggest challenges and hurdles in the connected vehicle space, and how is the group working to address these?
I can take that one to start. I think from our perspective, really the commercialization of the technology that we can specify is the issue that we think might be one of the biggest challenges. A lot of times, and I'm an engineer, so I'll plead guilty on this. A lot of times the challenge that we like to overcome is the technical one. Can we actually can we actually come up with a solution that will satisfy the requirements of this problem solution? But we oftentimes don't think of the commercial responsibility we have working for our company that makes that solution, viable from a product perspective. So one of the things that we're working on and what we tried to introduce today was building these proof of concepts that actually show commercial value to the solutions providers and to the use case definers, if you will, that actually want to have one of these features or one of these technical solutions as part of their product portfolio. So if we can ensure that that happens, and I think we're the organization that we have with this consortium and all of its different diversity of partnerships can start to demonstrate that commercial feasibility through examples like we showed today on the proof of concept implementations. So I think that's one of the bigger challenges we have and one of the ways that we're trying to solve it.
Yeah, that makes a lot of sense. Okay, and the last question we have, and Roger, I think you should take the first part of this one. They're asking, what are the biggest benefits of AEC membership for OEMs, MNOs, and cloud providers? So, Roger, what about for OEMs? What's the biggest benefit for OEMs?
Well, I think the idea that you can normally, let me take a step back. Normally in the automotive industry, at least in my experiences, automotive industry works with automotive industry. We can control the things that happen in the car and, within, 4 feet of the car. One of the benefits of the consortium like AECC is that the automotive industry can start to partner and collaborate and work with entities that have an influence on the way that their vehicle operates through the transportation ecosystem, I'll call it. So it's not only how the car operates by itself, but we're finding out that the importance of efficient and safe transportation involves the behavior of other road users as well. And I'm not even talking about privately owned vehicles as being the only category there. How does a vehicle operate with a truck? How does a vehicle operate with a traffic signal control? How does a vehicle operate with a pedestrian or a bicyclist, or a parking garage for that matter? So I think the benefit, and I think that benefit can be both ways. So I think the mobile network operators understand that the connected vehicle is a growing portion of their business, and that they need to kind of be present and understand the needs of the transportation domain or transportation vertical market, and help to address their connectivity solutions as ones that can comply with the requirements of connected vehicles.
All right, that makes sense. And what about for MNOs? Christer, do you want to take that part of the question?
Sure. I think both for mobile network operators and mobile network operator vendors like ourselves from Ericsson, I think the great thing here and with AECC is that we are working on, to Roger's point, we are working on things that relate to a business problem for the automotive ecosystem and market that exists today. And we are looking at things that really pose a problem for the automotive industry, which is not from an engineering point of view. Now we hear a dog in the background here, so that's interesting. So that is one key, that we actually work on a real problem. And I think for the MNOs as well is that, as I said before, there are many, if you look at the standardization such as 3GPP, there are many different standards or possibilities of deploying a network, configuring a network. But what we try to do here is to work with the industry to define that this is the way that it should be used. This is the choice that should be made. And for the MNOs that work directly with ACC or in close relations, such as we saw with Ericsson, Vodafone, and Toyota, then you will have a direct insight into how it will work for the automotive industry, and the OEM will absolutely have a possibility of using your network in the most efficient, both cost efficient and efficient overall way. So that is a really good opportunity for the mobile network operators to actually work on one of the biggest enterprise infrastructure type of business and I would say challenges for the next 5 to 10 years. I think it's a great opportunity for the MNOs to be part of that.
Okay, fantastic. And we have just a minute left, but the last part of the question is about the benefit of membership for public cloud providers. And also, which cloud providers are members of the AECC? Microsoft, I think, is a secondary member, but are there any other hyperscalers that are members of AECC?
Christy, I need to check the latest list here. So I think we have Google Cloud as well, but not sure the status of that one. So.
Fine, that's great. But what about just the overall? I mean, we've seen so much with all the hyperscale. Well, at least AWS and Azure have been getting into the connected vehicle space. So can you comment briefly before we close about the benefits for public cloud providers?
Yeah, I think it's obvious that it's very similar to mobile network operators. The difference maybe even more important is that, you know, in that space there is maybe not as much standardization to get the global consistent behavior. So I think then it's maybe even more important to be part of that, to understand the requirements from the vehicle industry, so that it's possible to have multi-vendor type of solutions, and that you should be able to use different clouds for different vehicle systems, so to say.
Right, and Google, of course, has its own connected vehicle initiative, so that's separate there. Okay, well, that is all the time we have, so I would like to thank all our panelists, Roger Berg, AECC Communications Vice Chair and Vice President of DENSO's North American Research and Development Group. Roger, thank you so much for being here and representing the automotive perspective so well today.
Thank you so much, Martha. I think this was a great webinar, good questions, good information share, and I hope that the audience understands the importance of our proof of concept initiative and chooses to contribute or work with us to establish what the future connected vehicle environment will look like.
Thank you. And Christer Boberg, AEC Secretary and Director of Group Strategy at Ericsson, thank you so much for representing the network and MNO perspective so well today.
Thank you so much for having me. I want to second what Roger said, but also want to say that this is a big opportunity, but also challenges for the mobile industry to support the future requirements that we see from ACC here. So, great opportunity to join in.
Thank you. And Bruno Fernandez-Ruiz, co-founder and CTO of Nexar, thank you very much for being here and educating us more about situational awareness.
Well, thank you, Martha, and thank you all World Live and the audience. And I'm actually really excited to be able to talk about this, being 7 years doing Nexar and finally having within the ACC a number of partners that can allow us to make this a reality and curb congestion and safety, improve safety on the roads, and save all those people that die unnecessarily on the road every year.
Yeah, it is very significant. Okay, and Tim Hatt, Head of Research at GSMA Intelligence, thank you so much for sharing your insights today.
It was my pleasure, Martha. It's great to be here and be part of this great discussion. I think we can all see the opportunity. Thank you.
And thank you all for joining us today. This will conclude our webinar.